This activity, using the area of squares to visualize the Pythagorean theorem, asks us to take our knowledge of the Pythagorean theorem to the next level and apply it to different situations, such as this one, where this area takes up 13 square units because the side length of this, all my work's here. Oh, that's great. The side length of this area is 13. The square root of 13. The side length of this one is 29.25 because it takes up 29.25 units. So to find x, we need to first add these two together, like I did. So that'd be 29.25 plus 13 gives us 42.25. But it's not asking us how much area it takes up, which is 42.25 units. It's asking us what the side length is. And the way we find the side length is by taking the square root of this. Now, this problem is difficult because I've been solving these for a few times to get the hang of it. And so that's why it's giving me a number that's not a perfect square. So I go to my calculator to find the square root of 42.25. And my calculator tells me that it's 6.5. But I only knew that because I used the calculator. Okay? Here, the area of the squares adjacent to the two sides of a right triangle are shown below. So we see that the big side is 44, the little side is 33 units. So we know that these two sides right here have to add up to 44. So we know that 33 plus x equals 44. So I could solve that by subtracting 33 from both sides, which gives us x as 11. Alright, here we have the diagram shows a right triangle and three squares. The area of the largest square, so the hypotenuse, is 36 units, which we know the square root would be 6. So if we know that this hypotenuse is 6, what could the sides of the smaller squares? Okay, so we know it can't be A because that includes 6. We know the hypotenuse has to be longer than the other two sides. Sorry, that was not right. Because it's not talking about side length, it's talking about the size, the area that it takes up. Okay? So, if this one was 6 and this one was 30, would 30 plus 6 equal 36? Yes, it would. If this was this was 28 and this was 8, 28 plus 8 will be 36. That one checks as well. If this was 16 and this was 4, 16 plus 4 would be 20. So that would not check. So we would just have A and B as our answers. And last, based on the areas of the squares, determine whether the triangle below is a right triangle. So as soon as I look at it, I say, yes, it's a right triangle. It looks like a right triangle. But what it's asking us to do is make sure that the side lengths work. So it's trying to make sure that 7 squared plus 18 squared equals 27 squared. 7 squared is 49 plus 18 squared is 324, and 27 squared is 729. So when I look at 49 plus 324, I get 373. Those are not equal, so it's no, not a right triangle.